Hello, I welcome you all. The problem reads the crash cushion for the highway barrier consists of a net of barriers filled with an impact absorbing material. The barrier stopping force is measured versus the vehicle penetration into the barrier. Determine the distance a car having a weight of 4,000 pounds will penetrate the barrier if it is originally traveling at 55 feet per second when it strikes the first barrier. This problem is coming from the Engineering Mechanics and Dynamics, our 14th edition by R.C. Benam. So to try and visualize what is happening, I try to bring in these particular details. So we have a car moving in this direction. Let's say it's moving in this direction like so. Okay. It has some velocity of equal to 55. This is initial velocity feet per second in this moving in this direction. Of course, we do have some weight for this particular vehicle. Let's say we have weight. Let me just move this so I have some space to indicate. So let me move it there. Oh, come on. Okay, I want to move everything. Well, it's fine. Let's leave it there. So let's say we do have the weight acting like so, and we have the normal force like so. And then imagine this vehicle hits, okay, as it is moving, it hits into this, okay, and as that happens, we have this reaction force there, and then there, which deforms this particular cushion. So let's say we have the displacement maybe up to somewhere there, just for argument's sake. So let's say we have displacement like so. Okay. Right. So let's say this point here is point 1, and then we have point 2. Okay. And this is our S. All right. This is our S, which is the deformation itself. Okay. This is the normal force from both wheels, from all the wheels, the 4 wheels, and this is the weight. All right, and this is the force. Okay, and this force is being determined by this particular cushion, which relates the force to the deformation. Right. Great. So we have this particular information like so, and the idea now is to calculate the amount of deformation in this crash cushion. But we've been given here a stepwise function. So we have the force, which is the function of the displacement, and this stepwise function. So when we have 9,000, mind you, is displayed in the y-axis in kips, and this is just equal to 1 pounds. Okay, 1 pounds. All right. So I'll convert this to pounds because even the weight is in pounds there. So 9,000 pounds, this is when the deformation is in the range 0 to 2. Then we do have 18,000 pounds, which is in the range from 2 to 5, right? And then we do have 27,000 pounds. This one is in the range 5 to 15. And then finally we have 36,000, and this one is in the range 15 Okay, this one is 5 here. 15 to 20. All right. So we need to find where this deformation takes place. Given the amount of work that is going to be done as this crash cushion gets deformed. All right, and we are going to use the principle of work and energy. So we are saying the total kinetic energy from point 1 plus, the initial kinetic energy at point 1 plus the total work from point 1 to point 2 is equal to the final kinetic energy at point 2. Right, since we do have the initial velocity of this particular car, therefore we'll say we have half, and kinetic energy is always positive because we are squaring the velocity. So this is going to be equal to half the mass of the car, which is 4,000 pounds divided by 32.2, and then times 55 squared. And then for the work, okay, for the work, we have the deformation, okay, we have the deformation in this direction while the force is in the opposite direction, right? So we have the force like so, seeing this force, and then we have the deformation like so. So this is giving us a negative work. So this is going to be equal to minus F times S, okay? And since this vehicle will come to a stop, okay, at 2, it will have to stop. Therefore, the final, the velocity is going to be 0 at 2, okay? Therefore, the final kinetic energy of the car will just be equal to 0, right? So with this equation, we are able to say Fs, which is the force times the displacement, okay, is just equal to 0.5 by 4,000. Okay, so there we go. We have 187 888.20 joules. All right, so this is what we have, but we are now being requested, of course, to determine the penetration depth. All right, but we don't know exactly where it is because we have just been given this stepwise function. So we know that the total area under this particular curve is equal to the work done. So we'll need to start now adding up these particular areas so that we see where we are going to have equilibrium, right? Okay. All right. So let's do so. So we are saying 9. What do we have? 9,000 by 2 is equal to 18,000. Of course, this is less than 187.88.20. Okay, then we are now saying 18,000 because we keep on adding, we are moving, right? So it's 18,000 plus 18 times the range for 18 is 5 minus 2, which is 3. Okay, and this is equal to so here we'll say not okay, sorry, not okay. All right, and then there we'll have 18,000 plus 18,000 by 3. This gives us a 72,000. This is still less than 187.888. Okay, 888.20, still not okay. And then we have 72,000 plus the next one is 27,000. Okay, by the range for 27 is 15 minus these are the ranges here, right? 15 minus 5, that's a 10. What does this one give us? So 72,000 plus 27,000 times 10. This gives us a 342,000, and of course this is greater than this. So we know to say the solution lies somewhere between 5 feet and 15 feet. That's a range. Alright, so we are going to set up an equation now. We'll set up an equation. We'll have added everything else. So all we'll do is we'll just say 72. We'll start from 72. Okay. And this 72 starts from 5 going this side here. Okay. Here going this side. Okay. So we are starting at 5. So 72,000 plus 27,000. Then let's just multiply by just some value S star. Okay, we are multiplying by a value S star, and we're saying this is equal to 187,888.20. We want to find that S star. At this stage, we'll say we'll make S star subject to the formula. So this will just be equal to 187,888.20 minus 72,000. Then we are dividing this by 27,000. Okay. Alright, so our S star, we have 187,888.20 minus 72,000 divided by 27,000. So this gives us our S star is just equal to 4.2922. Alright, but we are starting from 5 because we've already made use of this energy. Work has already been done here, right? So we just want to find an additional amount of energy that will allow us to equilibrate with this 187,888.20. And therefore, the total deformation itself, S, is just equal to 5 plus S star. Okay, and therefore our S total deformation or total penetration depth when this car strikes the barrier, the first barrier, will be equal to 9.22 feet. Okay, so if we are to show it here, we are saying it's going to be somewhere, maybe somewhere there. Okay, so it is going to be somewhere there, and the value of this is just a 9.2922 feet. Okay, and we are considering all this area here is equal to the total work done, right? Alright, given that speed in the problem, it will equate to this particular area. Okay, so let's just outline the solution like so. So there we go. So this is really about it, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.